And the answer is sort of yes, you can. So for instance, if you do A equals 1/2, let's talk about what that means. So if A is a half, B then has to be a half. Okay? And if B is a half, P is 1. So if you pick A as a half, this is called the Juan's method. And if you pick A to be, what is it here? Let me see, 0, then this is called second order Runge Kutta. I'll put RK. We'll talk about Runge Kutta more in a minute. So let's look at the difference here, what these things philosophically do. If you pick A to be half, then B is a half. Okay, so they're weighted equally. And then if B is a half, P is a half. P is 1. Okay? Now, so let's look at that. So P tells me where I'm going to evaluate this. So what this method does is says, let me take the slope here, weight it equally with the slope over there. So I sample the slope here, kind of take an average. Shoot across. That's it. Get you a better approximation, by the way. You can prove that. Let's go back now to A equals 0. If A equals 0, B is 1. So everything's weighted here. This is out. B is 1. If B is 1, P is a half. So P tells you where you're going to evaluate it. In this method, what you're going to do is say, I'm not going to evaluate the slope here or here. I'm just going to go halfway in between, try to get a value for the slope, and use that value of the slope. So I'm just going to take like an average point in time, try to pick the slope there, and then shoot across. Okay? Just different schemes, but they give you higher accuracy. All right, the most famous of them all is fourth order Runge Kutta. Well, I would say it's famous. It's kind of like Runge Kutta fourth order is like it's like oatmeal. It's like your bread and butter. It's one that like everybody kind of uses as a first try. Okay? It's good home cooking. All right. So here it is. It just simply says the following. My solution in the future is what it is now plus a little bit of something. And what it does, it evaluates 4 functions. Let me just tell you what it is, because I want to move on. It's all in the notes, by the way. The fourth order Runge Kutta, what people really like about this is if you do this, the error, and we'll talk more about that error later, is when you truncate, you evaluate that, and what you find is this, plus the remainder term is order delta t to the 5th. So whatever your step size happens to be, right? You take that small step size, you take to the 5th power, and then, all right. There's the error. So if I take step size of 0.01, that's 10 minus 2, every step I take, 10 to the minus 10 is my guaranteed accuracy. That's pretty amazing. So people like this. What are the 4 steps? This here evaluates the slope on the left. And what it does is it projects out halfway across, picks that number, uses it to project the slope in the middle, takes that approximation, uses it to a new projection of the slope in the middle, and then finally uses it to approximate a slope on the right-hand side. So what the Runge Kutta does is it says, to get to the future, I will sample the slope here, sample the slope here twice in the middle, and sample the slope on the other end. So 4 samplings of slope to try to get me from here to here as close to that dot as possible. Okay? That's Runge Kutta fourth order. Yeah?
Get those 3 equations.
How did I get these 3 equations? They were right in here. I popped them up. Okay. What I did is you can Taylor expand that, Taylor expand this. You match up the orders of delta t. Consistency has to have those. By the way, this calculation to actually derive fourth order Runge Kutta is maybe something you do once in your life. Maybe. It's not even clear it's worth it. I did it once. That's all I'm ever doing it. And I'm not even going to punish you by making you do it. Okay, so just trust me. You Taylor expand all these things, and you make all these things, you set them up just right so you get all the cancellations with all your coefficients. to get it down to that kind of error.